All right, so today we're going to work on translations of quadratics or transformations of quadratics, which means we're going to be looking at the 5 different types of transformations. Okay, so there are some characteristics of a quadratic function, especially when they're in vertex form, which control what the quadratic looks like. So we already know that we can see a smile or a frown. So if you remember, that's a reflection. And that was controlled by a negative a. So that's the one that we've already kind of looked at. So there are 4 other ones that we're going to talk about today. Rotation, which we don't use very much in algebra, but you'll see it in geometry. So we do want to talk about it real quick. We're going to talk about dilation. And then we're going to talk about translation. And with translation, there are 2. So you might remember something about sliding, about when we talk about translations. So let's go ahead and start with talking about reflection. So reflections can be across axes. So this one went from left to right, and this one went from up to down. So this one was across the x-axis. This one is about the y-axis. And these are always caused by negatives, okay? For our purposes, negative a, or the negative multiplier, is going to be what controls the reflection, okay? Now we also have rotation, which is spinning, okay? And that one you're going to talk about clockwise or counterclockwise. So clockwise means I'm going to turn to the right, and counterclockwise means I'm going to go to the left, okay? So this one, since I'm going to the left, is counterclockwise. And again, this one is not used very much in algebra, but it will be used a lot in geometry. Okay, so the next one that we use often in quadratics is what's called a dilation. And I like to think about this in terms of like zoom in, zoom out. So if you take your fingers in the middle of a picture on your phone and you spread them out, the picture, you zoom into that spot. If you pull it back, you zoom out. So we will see them take figures and stretch them horizontally or make them wider, or they'll compress them and make them either skinny or narrow. Okay, skinny or narrow. So if you take a look at what happened here on our quadratic, the blue one is what we call a parent function. That's the perfect function. Nothing has happened to it. That is the one that we always compare back to. If you notice that the purple one is skinnier, okay, it's definitely more narrow. And what has happened is there's a 4 there. Okay, there's a 4. So we're going to see that in quadratics, they're going to widen out or they're going to get more narrow or skinny. Same thing with shapes. You can zoom in, zoom out, make them bigger, make them smaller, depending on the motion. And this is called a dilation. Okay, dilation. All right, the next one is your translations. And these are the ones that you probably remember called sliding or slides. When we slide something or translate something, there's 2 directions, horizontal shift or vertical shift. So we're going to refer to horizontal as HS, and we're going to refer to vertical as VS. So when I'm looking at translating an object, I always start with the original object compared to the second object. And you can see how this one has as just A and this one is A prime. This is pronounced A prime. That tells me I'm moving from figure 1 to figure 2. So figure 1 is where I started, figure 2 is where I ended. And when you slide something or horizontally shift something, you take the entire figure and move it the same number of spots. Okay, so if I was to look at how far I moved point A, I moved point A 1, 2, 3, 4, 5, 6 spots to the right. And if I look at what happened to point B, 1, 2, 3, 4, 5, 6, it also moved 6 spots to the right. So everything on the shape has to move the same distance. Okay, otherwise it changes the shape. And when you are transforming and translating, it's a rigid motion. So you're just picking it up and sliding it. Now, sometimes you can actually have two shifts. So let's take a look at this one. So here's figure 1, here's figure 2. So this one, to go from A to A, I actually have two motions. So the first thing I did was a horizontal shift. 1, 2, 3, 4, 5, 6, 7. I went 7 to the left, or I did a -7 shift. Okay. Then what I did is I moved it down. Whoops. I think I counted wrong there. 1, 2, 3 spots. I moved it down 3. So this is a vertical shift of -3 down, or a vertical shift 3 down. Okay. So you can have multiple shifts there. And if I was to think about what happened with B, it would be the same thing. I would be moving 7 and 3. C would be 7 and 3. Again, when you're transforming, everything is rigid, so the shape has to stay the same. Now, this is the one that shows up the most often with our quadratics. Okay, so let's take a look at this transformation. There's 3 things that happened on from the red to the purple, okay, from the top one to the bottom one. So the top one, this is our parent function. This is x squared, okay? So we always compare back to the x squared. And the x squared, that one goes through 0, 0, and it actually kind of splits. It's kind of like in the middle of the quadrant, okay? So the first thing that I notice is that there's a reflection. And if I take a look at my problem, I see there's a -2 there, okay? So the negative is what caused the reflection. Now, the second thing I notice is that my vertex moved down 1, 2, 3, 4. So it was a vertical shift of 4. Okay, it was a vertical shift of 4 down. I could also write that as VS minus 4. Okay, VS minus 4 would be the same thing as a vertical shift down 4. Where would I get 4 from? Well, let's take a look at what we got here. If I was to distribute this, isn't that a -4? Yeah, so I'm going to see that a vertical shift can happen inside of my formula, my function, okay? Now, the third thing that happened is a dilation. This is definitely more narrow or skinny, okay? And remember, that can be called a compression. That's a vertical compression, okay? Which means I kind of smashed it together. So this is definitely not as wide as this is, okay? This is definitely more narrow. All right, so what we're going to do now is we're going to take a look at the functions, the parent function compared to 2 other functions to kind of figure out how does the quadratic function transform when we adjust it. Okay, so the first thing I want to look at is I want to look at these 3 functions. Remember, the middle one, the one that goes through 0, 0, this one is our parent. Now, let's take a look at what happened here. So the first thing that I want to point out is my vertex here, 1, 2, 3, 4. This was a vertical shift of -4. It went down. Now, this one was a vertical shift of +2. So let's take a look at what our functions are. So here's our parent function. Here's the blue function, x squared plus 2. Well, that's interesting because this +2 is my vertical shift. So that moved it up 2. And if I have this minus 4, that moved it down 4. So the impact of the positive 2 actually was a vertical shift plus 2. It moved it up 2. Okay, the negative 4 moved it down 4. So anytime I have a function like x squared plus 6, this would be a vertical shift up 6. If I had x squared minus 8, it's going to take my vertex and drop it 8 spots. If I had x squared minus 10, it's going to drop it 10 spots. Okay, it's going to move my vertex down. So anytime I add or subtract to the power of 2, so to my x squared, that is going to move it up and down. So vertical shift, adding or subtracting. All right, let's look at the next type of transformation. All right, so this time, here's my parent function. There's my x squared. And let's see what happened on this one. So the first thing that happened is a horizontal shift, positive 4 to the right. And this one was a horizontal shift of negative 2 to the left. Well, let's take a look at what our equations are. So first thing I want you to see is we have parentheses, okay? So if I have a horizontal shift, I am going to see parentheses. That has to happen. Now, the other thing that is interesting is that this is a plus 2 and this is a minus 2. Okay, it's a minus 2. It went the opposite direction. It went negative. So if this is positive, it's going to shift left. If it is negative, it's going to shift right. Okay, so if this is positive, that's a left shift. If I have the parentheses with a negative, that's a right shift. Okay, and this is opposite. It is always opposite. So you're looking for parentheses and you're looking for the opposite. So the plus 2 was a horizontal shift negative 2 to the left, or a horizontal shift of 2 to the left. The impact of the negative 4 was a horizontal shift 4 to the right. Okay, so again, it is opposite. So if I give you x minus 10 squared, the opposite is plus 10. That means I'm going to go to the right 10. That's a horizontal shift. If I give you x plus 3 squared, the opposite is negative 3. So that means I'm going to the left 3 with a horizontal shift. Okay, so again, opposites in parentheses. All right, now let's take a look at these. So again, we've got our parent function. And what I see on this one is I see that we are talking about a dilation. Okay, this one is skinny or narrow, and this one is wide. Okay, so I have skinny or narrow, and I have a wide. So this one would be stretched horizontally, and this one is compressed vertically. Okay, so let's look at what we have in terms of functions. So the purple one, or the pink one, that's this one. So what do you see there? Well, you see a fraction. So this is 1/3 x squared. So if I have a fraction less than 1, it's going to make it wider. Okay, if I have a fraction less than 1, it's going to make it wider. If I see a number greater than 1, so if I take a look at the next one, that's 2x squared, that's greater than 1, that's going to make it skinny. Okay, that's going to make it skinny. So anytime I have something in front of the x squared, that is going to change my dilation. okay? It's going to make it either wide or skinny or normal. Normal is going to be if it's a 1, okay? So 1x squared, that's normal. If it's bigger than that, it's going to be skinny. If it's smaller than 1, it's going to make it wide, okay? So the 2x made it skinny. The 1/3 made it wide. So anytime I multiply something, it's going to cause a dilation. Okay, it's going to cause a dilation. All right, so let's say I give you 4x squared. Is that wide or skinny? Yeah, that's skinny. What if I give you 0.25x squared? Yeah, that one's wide. Well, what if I give you 3 or 5/4 x squared? That one is actually going to be skinny. And the reason why is this is 1.25. Okay, so it has to be less than 1. So between 0 and 1 is where things are going to get wide. So pay attention to the multiplier to determine whether or not it's between 0 and 1 or if it's more than 1. Okay, so let's take a look at one more, and this one just pulls in the reflections, okay? So this one we're talking about reflections, and we already know that the reasons things reflect is we have a negative, okay? We have a negative. So if I have a negative 1/3, which is this blue one, then I have a reflection and I have a dilation. And it's a dilation that's wide. Okay, it's a dilation that's wide. If it's a -2, I have a reflection and I have a dilation that's skinny or narrow. So anytime I have a negative number in front of the function, that is going to reflect my function. Okay, that's going to reflect my function. And since I have no adding and subtracting, my vertex did not move. All right, so let's put this together to try to figure out kind of what's going on here. And we are not talking about dilations this time, okay? We're not going to be talking about dilations. We're simply looking at reflections. So we're going to be talking about reflections and horizontal shifts and vertical shifts. That's primarily what we're looking at right now, okay? If there's a dilation on your homework, it'll actually tell you what the dilation is because it's too hard to compare otherwise. So remember, this is my parent function. So it starts at 0, 0, okay? This is kind of like the perfect, and it is just a 1x squared. And remember, the type of function, this is a quadratic, and the name of this shape is a parabola. All right, so what happened from 0, 0? So how did I go from 0, 0 to here? 1, 2, 3, 4. Well, that is a vertical shift down of 4. So I can write that as Vs minus 4. I can write that a Vs down of 4. So my function, if you remember what happened, we've got two choices here. We have something like this, or we have x squared plus or minus a number. Well, which one of these was vertical? This was vertical, this was horizontal, and it was opposite, okay? So this function is going to be an x squared minus 4 because I moved it down 4. That's all I did. I just moved it down 4. All right, look at the next one. What happened from 0, 0 to here? Well, that is a vertical shift up of 4. So Vs plus 4 or Vs up, 4 up. So my function would be x squared plus 4. X squared plus 4. All right, now the next one, here's 0, 0. It moved to the right. 1, 2, 3 spots. So 3 spots to the right. Okay, so that is a horizontal shift of positive 3 to the right, or HS right 3. Well, how do I write that? Is that going to be x squared plus something? No, this one is the one that is the parentheses. So I have x, I have my 3, but remember, this is the one that is the opposite. So if I need to move positive 3, this needs to be a negative 3. Okay, that needs to be a negative 3. Okay, see what you can do with these 3, and I will catch up with you. All right, so if I take a look at what happened on this one, I see it's a horizontal shift left 3, or an HS negative 3. So my function would be x plus 3 squared. Remember, if it's a horizontal shift, it has to be opposite. Okay, and it's inside the parentheses. So same thing on this one. It would be x minus 5, because that's a positive 5. So a horizontal shift to the right of 5 would have to be x minus 5 squared, quantity squared, negative. Okay, opposite. Now this one's back to a vertical. 1, 2, 3, 4, 5. So x squared minus 5, because that's a vertical shift down 5, or vs negative 5. Okay, see what you can do with these 3. All right, let's see how you did. So this one has 2 things that happen. It has a reflection, which means I'm going to have a negative, and then it has a vertical shift up of 5. Okay, so I have a VS up 5. So I know I have an x squared. I know I have a plus 5. Where does the negative go? Well, the negative goes in front. Okay, this is what causes the reflection. So I need to have that negative 1 in front. Well, how does it look if it's a horizontal shift? Okay, so that's an HS minus 3. So a horizontal shift left of 3 and a reflection. So if I start with this part, I know that would be x plus 3 squared. So that is, remember, that's opposite. But then since it is a reflection, the negative goes in front. Okay, it goes in front. Well, what would this one be? I see it's a reflection. I see it's a vertical shift of 6. So negative x squared plus 6. And that one probably is dilated, but we're not going to deal with the dilation at this point. Okay, so go ahead and start your homework for today. If you start to struggle a little bit, come back and look at tomorrow's video. That might help you kind of keep moving. But reach out to us if you're struggling, and we're just about done with this chapter.